Welcome to Daily Papers, the podcast where we break down the latest research and what it means for you. Today, we're talking about chatbots and AI assistants. We've all used them, and let's be honest, the experience can be mixed.
Right. It's often great if you have a simple, straightforward question. But what happens when you're in the middle of a conversation with an AI and you suddenly change your mind, or you remember something else you need to do?
Exactly. Imagine you're talking to your bank's AI assistant. You start by saying, "I want to check my balance." The AI gets to work. But then you remember, oh wait, actually, before you do that, can you help me dispute a weird charge I just saw?
That's a classic human moment, and it's a moment where a lot of AI systems tend to get very, very confused. They were on a mission to check your balance, and now you've thrown a wrench in the works. This exact problem is what a new paper called AgentChangeBench is all about.
It's by a team of researchers from Pooch AI, Algoverse, and Microsoft, and they argue that we've been testing our AIs all wrong. Most current tests are like a final exam with a bunch of simple one-off questions. The AI either gets it right or it gets it wrong, pass or fail.
But that's not how real conversations work. Real conversations are messy and unpredictable. The researchers point out that these simple pass-fail tests assume we, the users, have one single goal that never changes. They don't measure how well an AI can adapt.
So this team built a new testing ground, a new evaluation framework, which they call AgentChangeBench. You can think of it as a much more realistic obstacle course for AI assistants. It's specifically designed to test how they handle these goal shifts, the moments we change our minds.
And they made this obstacle course really challenging. First, they focused on 3 areas where people interact with AI all the time: banking, airline bookings, and online retail. These are complex tasks where things can definitely change on the fly.
But the really fun part is that they also created 5 different user personas for the AI to interact with. These aren't just generic users. They're simulated people with distinct personalities.
Yeah, this is great. For example, there's a persona called easy_1 who is polite, patient, and says things like, "Please walk me through this." Then you have medium_1 who is all business, impatient, and says, "I need this done quickly." And my personal favorite, hard_1, who is suspicious, questions everything, and asks, "How do I know this is secure?"
By throwing these different personalities and mid-conversation goal changes at the AI, the researchers can see not just if the AI completes the task, but how well it handles the stress and uncertainty of a realistic conversation.
And to do that, they needed a new scoring system. The old pass or fail grade just wasn't going to cut it. So they came up with 4 new ways to measure performance.
The first one is called the task success rate, or TSR. Instead of a simple yes or no, this is more like getting partial credit. Did the AI get most of the task right? Did it communicate clearly? Did it follow the rules? It gives a more nuanced picture of success.
Next is tool use efficiency, or TUE. This basically asks, did the AI use its tools correctly? Conversational AIs have to access databases or process payments. Those are their tools. This metric checks if the AI is pressing the right virtual buttons to get the job done.
Then there's my favorite, the tool call redundancy rate, or TCCR. This is essentially the AI's annoyance factor. Does it keep asking for your booking number over and over again, even after you've already given it? Does it check the same flight status twice in a row? This metric measures that kind of wasteful, frustrating behavior.
And finally, the most important one for this paper, the goal shift recovery time, or GSRT. This measures how quickly the AI catches on when you change your mind. When you say, "Actually, never mind that, let's do this instead." Does it pivot immediately, or does it get stuck for a few turns, still trying to complete your old request? It's all about its recovery speed.
So with this new obstacle course and new scoring system, they put some of today's top AI models to the test. And the results were fascinating. They found some huge differences between models that older, simpler tests would have completely missed.
Absolutely. For example, in the airline booking tasks, when a user changed their mind, the GPT-4o model was a star. It recovered and got back on track over 92% of the time. But the Gemini model really struggled, recovering less than half the time, only about 48%. That's a huge difference in user experience.
And what about that redundancy metric, the annoyance factor?
It was a huge issue, especially in retail tasks. The paper found that some models had redundancy rates above 80%. That means that for every 5 actions the AI took, 4 of them were just wasteful, repeated actions. It was essentially spinning its wheels, costing time and, for the company running it, real money.
Wow, so the big takeaway here is that an AI can seem very smart and get a high score on a simple test, but completely fall apart when faced with the kind of curveballs that humans throw all the time. High accuracy doesn't mean it's robust or pleasant to work with.
Exactly. This isn't just an academic exercise. As we start using AI assistants for more and more important parts of our lives, managing our finances, booking complex travel, handling customer service, we need to be sure they can actually handle a real, dynamic, human conversation.
This research gives developers a way to measure that. It pushes them to build AI that is more resilient, more efficient, and just less frustrating to talk to.
It's about making AI assistants that can adapt to us instead of forcing us to adapt to them. It's a huge step toward making them feel less like rigid, fragile tools and more like genuinely helpful partners.